Hi and welcome to Sentinel-AI, the one-stop solution to train and deploy your models securely and chat with the Flocks RAG model. Let's begin with the architecture of our project. So as you can see, this is the architecture of our project, which mainly consists of the client side and the RAG model, which we are calling in the backend. So now let's see how the initial prompt setup works. So when a user gives a prompt to the RAG model or the LLM, the LLM in response returns some data. So for that, we have trained the Flock API's co-creation RAG model on such a heavy amount of data so that it can give us the perfect results. So let's try out what we have trained. So we'll go to the project and let's see what we have trained. So here we are. So here we'll just first connect to the wallet and then write a prompt like, hey, can you assist me with training my AI model? So I send the message. So let's wait for the RAG model to give us the data which we have trained it on. As you can see, the model has successfully replied us, and you can see how to train the model. We have trained the model on the NLP, which gives us the natural response whenever we text it. You can try out another prompts. Uh, you can try out another prompts like this. What are hyperparameters meters while training a model? So now let's send a message. Now let's wait for the RAG model to give us a response. As you can see, the model has successfully replied to us by giving the in detail description how what are hyperparameters while training a model, the epochs, and the most common values which we need while training the model. So now let's move into our second feature, which is the file upload feature. I'll explain here what the file upload feature does. Or it is basically when user needs a trusted source of data to train its model, it becomes very hard to find such data. So our AI prompt assistant based service solves this issue by letting user to just store the data by using a prompt and then generating a ZK proof for it. So for that, we have used Flock AI co-creation uh, and the ZK pass schema generation. The ZK pass schema generation, which we have used, successfully generates the ZK proof schema, which later on can be used for verification and for proving the authenticity of the data. As you can see, when the client uploads the document to the IPFS, at the same time we generate the ZK pass schema. Now let's try out here. So when suppose a user types a query like, can you help me to upload the file? Now let's wait for the response of the AI. So here is the response of the AI. Now we'll just choose the file which we want to upload and then upload it to the IPFS. As you can see, we have successfully generated the link. We can visit the link by simply copying this and then pasting it here and see which file we have uploaded. As you can see, this is the file we have uploaded, and we can generate the schema for this file, and it will be get download here. You can see the schema is generated here. I'll show it. We can upload the schema to the page like this. This is the schema with the which is generated for the zkpass schema validation. So we'll paste it here and add a custom schema which we want to just prove. So as you can see, the name of the schema should be IPFS file. So category of the is educational, and we can simply check the schema and then see. So moving on further, we have another feature of deploying the training node of Flock Arena by just giving the simple prompts. For that, I'll explain the backend logic behind it. So when a user enters the prompt of deploying a training node, then we have a executable bash file which runs under the hood and then uploads the entire LLM to the Hugging Face platform. So for that, AWS server, and then it takes the input data from the S3 buckets and deploys it to the Hugging Face. So we'll just demonstrate it here. So if a user hits a query like, can you help me deploying training node for Gamma model, which is an open source model by the Google. So we'll just send a message and wait for the model to just reply. So as you can see, these are the fields which we take and run the bash script in the backend. So we take the flock ID for now, task ID, and the flock ID which we have generated before. The test token would be something like this, and then the Hugging Face username. So my Hugging Face username was a test. So I'll submit the form, and then it will pick up these values and deploy the training node for me in the backend. As you can see, the script has started running, and we have deployed the training node using the AI prompt. So let's wait for the training node to get entirely deployed. As you can see, the training node has been deployed and we are inside the training node directory. Now suppose it only deploys the training node, but if we want to just deploy the Hugging Face, the model to the Hugging Face platform, then we will enter the prompt like, can you submit a model to Hugging Face? So we'll just implement this prompt. So as you can see, we have the form like this, which takes the task ID, which we have deployed, the same flock ID, and the same Hugging repo ID, which we will get on the Hugging Face interface. So for now, I'll just keep it as a test, and I'll demonstrate it onto you, and we'll just submit the form. After submitting, this deploys the and training node and submits the model to the Hugging Face repo. So yeah, this was all about the RAG model feature of Flock AI. Now let's move to the biodata section, where there are various models, open source model that we have listed here. So once we deploy the script or the model, it gives us the message like deployment action successfully simulated successfully. Uh, After the deployment is done, the model is uploaded and a ZK proof of the model is calculated behind the scene. These are the models which we have trained ourselves by just and creating the ZK pass proof in the backend. So I'll just click the OK button for now, and I'll showcase the RAG model which we have trained for this hackathon. So this is the Hugging Face. So this is the Flock AI's RAG model for this hackathon, which is named as Blockchain GPT. You can check this out. Uh, Also, we are trying to implement some cool features in future for the deployment of model and analyzing its view, but it's currently under development. So when there is a selective model, we can just apply the model training algorithms like linear regression, logistic regression to it, and get an overview of it using the graph. So yeah, that's all about it. But last but not least, we have the dashboard section, gives you the which gives us the overall interface for looking out what's happening in the Sentinel AI. So yeah, thank you.